All right, let's look at this exponential equation. Again, from the first video for these equations, we saw that we were hoping that the bases were the same. The bases are not the same. So the second one, I mentioned in the first video, there's a easy, medium, and a hard. Easy was when the bases are the same. That's not the case here. The medium is when we can look at the largest base, 8, in this example, and it can be rewritten with the lower base. So the question we have to ask ourselves here, can 8 be rewritten with a base of 2? Well, it can, because 2 times 2 times 2 is 8. So 2 to the third power is 8. So I looked at my larger base, 8. I saw if it could be rewritten as the smaller base here, which was 2, and it could. So I'm just going to do that. It'd be like saying if we had an equation with 25 in it and I just rewrote it as 5 times 5. It's really the same thing. So this equation that I'm writing right now on the second line, it's the same as the original equation because 2 to the third is 8. So these equations are the same. Now I have to do a little bit of simplifying. I'm going to do 2 to the third to the power of x plus 1. Now we know in our rules when I have a power of a power like this, I have to multiply. So I'm going to multiply these exponents. So I'm really going to do 3 times x plus 1, which is 3x plus 3. And then that equals the other side, 2 to the power of 2x minus 3. Now we're actually to the point where we do have the same base. And we learned in the last video that when they have the same base, they have to have the same exponent. So when the bases equal each other like they do now, the exponents have to equal each other. So the first exponent, 3x plus 3, equals the other exponent, 2x minus 3, and now I can solve this little equation right here. I can subtract this 3 from both sides and get 2x. I'm going to subtract 3 from here, so that would be minus 6. And then subtract this 2x from both sides, which is going to leave me with x equals negative 6. And that is my answer.